Hi there, this is Waves Lesson 5, and this is Uses of the Electromagnetic Spectrum, Part 2. So the objective is recall and explain the different uses of visible light, ultraviolet, X-rays, and gamma rays. So in the previous lesson we did radio waves, microwaves, and infrared. So this is the second half of the spectrum. So let's start with visible light. So this is a visible light coming into a glass pyramid and then undertaking a change in direction called refraction, and then diffracting out the right hand side in all the different colours of the rainbow. So let's look at that now. So visible light will split into a colour spectrum, and here it is. So it's red, orange, yellow, green, blue, indigo, violet. So visible light is emitted from hot objects like the sun, and visible light has wavelengths ranging from 0.000004 meters to, same again but 7. That's 400 to 700 nanometers. So 400 nanometers to 700 nanometers. Nano basically means divide by 1 billion. So if you got a meter and divided it by a billion, and then took either 400 or 700 of those, they're your wavelengths of visible light, so really small. In terms of energy and stuff, we discussed this a few lessons ago, but radio waves is the longest wavelength, the lowest energy, and the lowest frequency. In terms of the spectrum, it goes radio, microwaves, infrared, red, orange, yellow, green, blue, indigo, violet, ultraviolet, X-rays, gamma. So, red must be the longest wavelength, the lowest energy, and the lowest frequency. And the violet side is obviously more energy, so high energy, shorter wavelength, and higher frequency. Okay, let's move on. So let's look at some uses of visible light. So visible light, sight, obviously to see things, photography, optical fibres for transferring the information down the fibre, and of course another major one, photosynthesis, which is where plants get their energy. Okay, let's move on. Let's look at ultraviolet next. So there's some uses of ultraviolet. So security markings show up under UV light. Ultraviolet is also emitted by the sun. And fluorescent lamps and energy efficient bulbs work using UV as well. So let's look at where the ultraviolet lies on the electromagnetic spectrum. So here it is. So we're getting a bit more energetic now. Remember, the further we get down, the more energy, the higher the frequency, but the shorter the wavelength. So ultraviolet has a wavelength of typically a tenth of a millionth of a meter. UV is produced from very hot objects like the sun or from special electrical tubes. Most of the sun's ultraviolet radiation is absorbed by the ozone layer in the upper part of the Earth's atmosphere. UV is also stopped by glass. Okay, let's move on. Let's look at some uses. So here we go with some uses. So ultraviolet is used in fluorescent lamps, including energy efficient light bulbs, security devices, like this debit card, Visa debit card on the right hand side, dentistry. So the UV light in dentistry, you've got a few uses. One that I've had personally is the fillings. So they use the UV light to get the composite to bond really quickly, so you can put a filling in very quickly. Got pest control and astronomy. You might have realised by now that we can use every part of the electromagnetic spectrum for astronomy, all the way from radio, all the way down to gamma rays. Remember to pause at any point if you wish to make any notes. Let's move on. Let's look at safety with ultraviolet light. So the sun's ultraviolet light is responsible for suntan. And too much exposure to UV can cause blindness, or more commonly skin cancer. And obviously different skin cancers have a different prognosis and different outcomes. Some are quite mild, and some, such as a melanoma, can be very dangerous. So to protect, number one, wear a hat, especially if you've got short hair. Sunglasses with UV protection is another good idea. Cover up when the sun is the strongest or the brightest, normally between the hours of 12 and 3. Longer shorts offer more protection. And maybe most important, use a high sun protection factor sunscreen and reapply, as directed on the bottle. All right. Hopefully that makes sense. You probably knew quite a lot of that anyway, but let's move on. So next down the spectrum is X-rays. So we can have X-ray photographs. You will most likely know that, and you've probably had an X-ray before, or you will definitely know somebody who's had an X-ray. We can also look at exploding stars using X-rays, as they emit X-rays, high energy X-rays. Okay, let's move on. So we're near the bottom of the spectrum now. So X-rays, more energy than ultraviolet, higher frequency and shorter wavelength. So X-rays have wavelengths of typically a billionth of a meter. They're produced from X-ray tubes that use very high voltage, typically 100,000 volts, so that would be the way that the X-rays are produced in a hospital setting. They're very penetrating and are only stopped by several centimeters of lead. Oh, sorry. So if you need to make any notes on that, please do. Okay, let's move on. Right then, uses of X-rays. Some cool pictures there. Well done if you've spotted this mistake. Don't know why that says ultraviolet. X-rays. X-rays are, there we go. X-rays are used in, so we've got X-ray photographs, which we've already discussed. Airport security, that's a good one. So you could probably guess what that is. So if you were working in airport security and this bag came through and you saw that bag, you would probably want to open that up and take that machete-looking big knife thing out. So obviously someone's up to no good. Cancer treatment, bottom right-hand corner. And astronomy. Okay, let's move on. So how about taking an X-ray? So let's discuss this one a little bit. So X-rays can pass through soft tissue. So in terms of you or another human being, that's basically everything but bone. So X-rays pass through all the soft tissue but are absorbed by bones. So X-rays are directed onto the patient from the X-ray tube above, as you can see on this photograph on the right. And then a light-proof cassette containing a photographic film is placed on the opposite side of the patient. Remember to pause if you want to make any notes. I'm going to move on to another slide now. So when an X-ray tube is switched on, the X-rays pass through the patient's body, leaving a shadow image on the film showing the bones, because obviously the X-rays can't pass through the bones. So when the film is developed, the parts exposed by or to the X-rays are darker than the other parts, and the bones show up as lighter regions on the radiograph. So basically on the right hand side, the dark areas are where the X-rays have managed to get through, so in between the ribs and out the ribs at the other side to the photographic plate, and the parts that are white is where no X-rays have gone through and they've been absorbed by the bone, which lets us obviously see the bones. So it's quite simple really, but obviously very useful in dentistry and in a hospital setting. Okay, let's move on. So next we're going to look at gamma rays, which are basically X-rays but with even more energy, shorter wavelength and higher frequencies. So some cool gifts. Gamma rays given off by nuclear explosions, and gamma rays are also emitted from material falling into black holes. They're known as gamma ray bursts. If you want to learn about gamma ray bursts, I suggest you Google it. They're quite terrifying in what they can do, but also very interesting. So gamma rays are at the bottom end of the spectrum now. So the highest energy, the shortest wavelength, and the highest frequency. So gamma rays have the shortest wavelengths of the electromagnetic spectrum, typically a millionth of a meter. So if you've got a meter ruler and split it into a million, equal pieces, and then got one of those pieces and then divided it by a million again, we're getting pretty small. So they're emitted by radioactive substances. They are very penetrating and are only stopped by several centimeters of lead. Which obviously they're very dangerous, or can be very dangerous, but we've also got some uses, some medical uses, and uses in like food production and killing bacteria and so on. So let's have a look at those. So gamma rays are used to kill cancer cells, to kill harmful bacteria in food, and to sterilize surgical instruments. So on the right hand side is a 6th generation gamma rays knife being used to treat cancer, and treatments for cancer are getting more and more advanced. And this machine on the right, the selector icon, is designed to treat cancer very quickly. So you're exposed to lower amounts of gamma radiation, which means less chance of any harmful side effects. Okay, let's move on. Remember to pause at any point if you need to take any notes. So let's move on to safety. So safety with gamma and X-rays. So too much exposure to gamma rays or X-rays is indeed dangerous. High doses can kill living cells, and low doses can cause cell mutation and cancerous growth. So workers who use equipment producing gamma or X-rays wear a film badge called a dose meter. The film in the badge darkens if the person receives too high a dose of radiation. And I imagine most companies, if you receive too much radiation over a too short a period of time, you would basically just be sent home, obviously to limit the exposure, because obviously too much exposure is very dangerous. All right, let's move on to a closed exercise word fill to finish with. So if you want to do this without the keywords, if you're super smart, then pause the video now. Okay, I'll put the keywords on if you need the help. They'll go on now. And then I'll take you through the answers. So gamma and X-rays are the most dangerous radiations of the electromagnetic spectrum. Both can cause cell mutation and cancerous growth, although both can also be used to treat cancer. Both require several centimeters of lead to be stopped. X-rays are absorbed by bones, allowing the production of radiographs. Gamma rays are used to kill bacteria in food and to sterilize medical instruments. So the last two video lessons will have covered the uses of the electromagnetic spectrum. I hope you found that helpful. And thanks for watching, and I'll speak to you soon.